2.6 is constructing functions with variation. However far I get today, we'll pause. I'll post a video to finish it up so that we can stay on track for after spring break. And hopefully we all come back and that works out really well. So constructing functions with variation, I have a lot of writing for you to do, unfortunately, in this section. So let me start with this type. So we have several types of variation, 3 in particular that we're going to talk about. The first variation is called direct variation. The 3 sort of check-marked pieces at the beginning, well, actually the first 2, are just language components that mean the same thing. You can see, like in a word problem, it will say either y varies directly as x, or it might use the language that says y is directly proportional to x. And of course, the key word in both of those is the word direct. So if it's direct relationship or a direct variation, it's going to say it's direct. The k value that I'm going to have in my equation below is actually called the constant of variation or the proportionality constant. So k is a constant, which means it's just a number. And the equation for direct variation is y equals kx. And the only consideration is k is not 0. So these are very straightforward lines, probably the first lines you ever saw. You just didn't know that they were called direct variation, right? Y equals x, y equals 2x, y equals 5x, y equals negative 7x. All direct variation. And the reason that language is used is because what it's saying is that x varies a little bit like this, then y always varies like that. Okay? A direct variation that you use all the time is anytime you go shopping and buy more than one of an item. On the shelf, it says $2 for the box of Hamburger Helper, and you buy 3 boxes, then it's going to be $2 times 3 boxes, right? Or you can talk about the money in your wallet that happens when that happens. It is now negative $2 times your 3 boxes. It is out of your pocket of your money, right? You use direct variation all the time. You just didn't know that's what it's called. Now there's another relationship. The second one is called inverse variation. So the couple of phrases that mean the same thing are that y varies inversely as x, or that y is inversely proportional to x. And of course, the key word again is inverse. And instead of saying that y is k times x, it's y is k divided by x, the inverse operation of multiplication, division. So inverse variation would probably be what the general consensus or thought is right now for the virus that's spreading. If people travel less, fewer people get the flu, right? So more travel means that we have more exposure. And so there's this relationship that says that the more you stay home, the less you get sick. Let me say it that way. The more you stay away from people, the less exposure you have. Okay, so that's an inverse type of relationship. You could also think about, like in the summertime, a thermostat at a house, right? The hotter it is, the more you turn the air down, right? And the higher your electricity bill goes. I know you probably don't pay your electricity bill, but I think you have an idea of how that probably works in your home, right? I bet your parents probably have told you at some point, don't turn the air down below this. I've told that to all my children. Don't you touch my thermostat. It's expensive when you do, okay? Now, there is one more. It's called joint variation. Y varies jointly as x and z, or y is jointly proportional to x and z. Again, the key word is joint, or jointly. So, your equation says y equals k times x times z. Again, k is not 0. K is not 0 in any of these. But this would be a relationship where there's 2 variables that are affecting an outcome. For example, right now, if you go to the store, you might have two things affecting your decision about whether to buy a particular product, like toilet paper. How many are on the shelf and how much it costs. Because I'll tell you, I went last night and I tried to buy Kleenex, and I didn't even think about it. I was just going to buy Kleenex because this, we've been blowing our noses and the Kleenexes are running low, and I was going to buy Kleenex. And I don't buy name brand because that's expensive. I always buy generic. And there's a few name brand on the shelf, and I said, nope, no thanks. Because the cost was more than I was willing to pay, even though there were a few on the shelf, and there were only a few. Okay? So there's two variables that are affecting the decision that's made. There's two variables that are affecting the outcome. And that's what you see here. X and Z are both having a direct relationship, comparison relationship to the value Y. All right, so we've got some examples. So these are like real examples instead of me making things up about current events. So it says we're going to construct a function to express each statement. So it just means we're going to write one of these equations. So our equations are going to be either y equals k times x, y equals k divided by x, or y equals k xz. They're all going to look like that. Okay? We only have three choices. It's almost like multiple choice. You only have three options. Okay. So taking a look at this first one, it says the amount of sales tax is directly proportional to the purchase price. Somebody tell me the key word you just saw or heard. Directly. It's multiple choice. Okay, so look back up in your notes. I'm not going to flip on my screen, but look back up in your notes. And the equation in your notes says y equals kx for direct proportions, right? So you grab that equation, y equals kx, and you're going to write that equation for this context. So we kind of like to use variables a lot in this kind of thing that represent the quantity. For example, this says sales tax, so maybe you use the letter S or the letter T for sales tax. I'm going to go with T because S's tend to sometimes look like 5s. So I'm going to do T equals. The tax equals. Okay, K, unless we're given a value, is always going to stay K. And then it says it's directly proportional to the purchase price. So what letter might you like to use for purchase price? P would be great. T equals KP. It's the whole problem. Okay? Next one. We actually saw a silo driving down the road the other day, by the way. It's kind of funny. The volume of a grain silo, they're huge, absolutely enormous. The volume of a grain silo can hold, the volume a grain silo can hold varies jointly with the height and the square of the radius. What's the key word you see? Jointly. And if you flip back in your notes or flip up or look up, it says y equals k x z. This one's a little different. We're going to start out the same. It says the volume a grain silo can hold. So what are we going to let volume be? Letter? V would be great. Volume equals, and it's always going to have that K. And then it says with the height. So what might we want to use for height? H would be great. The next part's the part that's a little different. It says the square of the radius. So how do you think we might represent that? R squared, exactly, Aspen. Perfect. Because it said square in it. So we're going to square the letter that we're using to represent a radius. Easy enough? Seem reasonable? Okay, we're going to go in reverse now. So we're going to write each formula in words using the vocabulary of variation. I realize that you may not be familiar with on the first equation, but you might. Does anybody know what that equation is representing? C equals pi d. Have you seen it recently enough to remember it? It's not circle, but it is something to do with a circle. Circumference. Any idea what D might be? diameter. So this is just a side. I'm not expecting that you remember it. It's okay. It's circumference and diameter, and it's interesting because it's got the number pi in there. And do you know what tomorrow is? It's Pi Day. You should definitely eat some pie. It is Pi Day because it's March 14th, 3.14. Yeah, isn't that cool? You guys have learned something very useful today because you should definitely eat pie tomorrow. Yeah, so 3.14. Anyway, this is going to be it says using the language of variation, okay? So what that means is that first you need to identify which of the three types of variation is this. Is it direct variation, joint variation, or is it inverse variation? Which of those equations? It's direct. So this is direct variation. So I'm just going to write myself kind of a note. Now, if you didn't know what the quantities represented, you wouldn't actually say circumference for C, and that would be okay. We'll do that on the next problem. But we do know on this one, so we're going to. This is the circumference. And you have the choice. You can say is directly proportional or varies directly. You can use any of those language pieces over there for direct variation. Okay, so you can say varies directly or is directly proportional. Which one do you want to use? Varies directly. We'll go with that one. So circumference varies directly. As the diameter, with respect to the diameter, you got to say something about diameter. I am not an English teacher, so if your language is not quite grammatically correct, we'll be okay. Okay? It varies directly as the diameter. So direct variation.
So math way, are we going to have to know what those are?
No. It'll be more like the next one where you've got this random equation where you've got all these pieces like this. So it would say something like this. B, or let me actually just say it in respect to part A, and then we'll stop and I'll put the rest on a video for you. You would say something like this. C varies directly with respect to the diameter, or with respect to D. You could just say, so in other words, where we wrote circumference, you could say C, and where we wrote diameter, you could say D, and it would be okay. And that's what will happen on part B and so forth. The part that's actually still left is just, there's more writing to it. It looks like it's longer in my notes, but I really only have I only have 5 problems left. So probably what I'll do is I'll look and see if I've recorded this before and just post that video, and I'll tell you where to start the video to pick up on the rest of the lesson, okay? All right, have a wonderful spring break. I will see you hopefully in like 9 days. That's the goal, or 10 or whatever it is, the day we're supposed to come back.